All right, welcome back. Today, we're diving into what is seriously a David versus Goliath story, but from the world of AI. We're talking about a tiny model that is outthinking some of the industry's biggest giants. And look, this isn't science fiction, it's a real breakthrough, and it could honestly change everything.
So it all kicks off with this wild claim from engineering leader and edge AI strategist Fani Bhushan Author. He points out that a 7-time million parameter model, and you can just think of parameters as the little building blocks of an AI's brain, is beating a 671 billion parameter model. This isn't just a small improvement, you guys. This is a whole paradigm shift.
Let's just let that number sink in for a second. 0.01%. We're talking about getting way better results on really hard problems using a tiny fraction of the size. This isn't about being a little more efficient. This is like rewriting the rulebook from scratch. Okay, so the big question is, how is that even possible? Well, this is the story of something called the Tiny Recursive Model, or TRM, and it's a true giant slayer in the world of artificial intelligence. And that's really the core question we're digging into today. It's a mystery that just completely challenges one of the biggest assumptions in AI right now, that bigger is always better. But as you're about to see, the answer has less to do with brute force and a whole lot more to do with a clever new way of thinking. So to really wrap our heads around this, we first need to understand the two extremes of the AI landscape. It's really a tale of two completely different worlds. And Fanny Affler paints this brilliant picture for us. On one side, you've got the AI skyscrapers. These are the huge, large language models, the LLMs like ChatGPT. They live in the cloud, they need massive data centers, and they just guzzle energy to run. But on the other side, you have the AI Fireflies. These are tiny models from a field called TinyML, and they're so small and efficient they could light up billions of everyday devices, sometimes running for years on a single coin battery. So how in the world does a tiny firefly take on a massive skyscraper? Well, its secret weapon is this really cool technique called recursive reasoning. And here's the crucial point. This isn't just an upgrade. It's like they threw out the old blueprint entirely. The breakthrough didn't come from just stuffing the model with more data or adding more parameters. Nope. It came from teaching it how to solve problems in a fundamentally smarter, more human-like way. So, what exactly is recursive reasoning? Okay, imagine you're solving a really tough math problem. You don't just magically write down the final answer, right? You work through it, you check your steps, you might find a mistake, and you go back and correct it. You iterate. That is exactly what this tiny model does. It thinks, it checks its own logic, and it refines its answer over and over again. If we break it down, the process is actually kind of beautiful in its simplicity. First, the model makes a first guess. Then, and this is the key part, it critically reviews that guess. It asks itself, hey, does this actually make sense? Did I miss something? It finds the flaws in its own thinking, fixes them, and then runs the whole cycle again and again until it's confident that the solution is solid. Now, this all sounds great in theory, but what does this process of thinking actually look like under the hood? Let's take a quick peek at the architecture. Yeah, how does a 7 million parameter model, which, let's be honest, is microscopic by today's standards, actually pull off this kind of complex, multi-step reasoning? Okay, I know this diagram looks a little intimidating, so let's just focus on the most important part. See those arrows that are looping back on themselves? That right there, that's the recursion in action. The model takes the question, its first guess, and its own internal thought process, and it feeds it all back into itself to try again. It's a cycle of nonstop self-improvement built right into its core. We can actually simplify this whole thing down to two key jobs. You've got an inner loop, where the model is just working on its internal thought process, its chain of reasoning. Think of this as the model just thinking to itself, kind of mumbling through the problem. Then you have the outer loop, where it uses that improved reasoning to update its final answer. So it thinks, then it acts, and it just keeps doing that over and over. So we've seen the theory, we've peeked at the architecture, but does it actually work? Let's look at the hard data that proves this whole less is more thing isn't just a clever idea. It's a validated breakthrough. The researchers put this little model to the ultimate test. They used something called the ARC-AGI benchmark. It's a notoriously difficult set of abstract reasoning puzzles that are designed to trip up even the most advanced AI. And the results? Well, they were pretty staggering. And here it is. This is the proof in the pudding. Just look at the Tiny Recursive Model, TRM, right there at the bottom. With only 7 million parameters, it scores almost 45% on the first test. Now compare that to DeepSeek R1 with its 671 times billion parameters, which only got about 16%. It's not even a fair fight. TRM is just crushing models that are thousands of times its size. So this huge win for the less is more camp doesn't actually mean it's the end of the road for those giant AI models. Not at all. Instead, what it's pointing to is a future where we have two very distinct but also complementary types of AI. And that brings us right back to the skyscrapers and the Fireflies. The giant LLMs are still going to be the kings of creativity, of generating text and images, and handling high-level strategy from the cloud. But these tiny, super efficient TRMs, they're going to be the masters of on-device reasoning, making local decisions and sensing the world around us. They're really two sides of the same incredible coin.
So why should you actually care about any of this? Well, first, sustainability. This is AI that barely sips power. Second, privacy. When all the thinking happens on your device, guess what? Your data stays on your device. Third, accessibility. This can bring real, useful intelligence to billions of simple, everyday objects. And finally, innovation. This is the ultimate proof that the future of AI isn't just a race to build bigger, more expensive models, it's also a race to build smarter algorithms. And that brings us to the final, most important takeaway. And it's summed up perfectly by the strategist whose commentary got us started, Fanny Othler. The future isn't a choice between the skyscraper and the firefly. It's about building an entire ecosystem where they both thrive, working together to create a smarter, faster, more efficient world for all of us.
And that really just leaves us with a final thought to chew on. We are right on the edge of a world where powerful, efficient reasoning isn't just locked away in some distant cloud, but it's in your hand, it's in your car, it's in your home. The question isn't if this is going to happen anymore, it's how is it going to reshape absolutely everything.